Yeah, hi Arun sir.
Yes, hi.
Yeah. So I think good to go. We can start with the session. And guys, batch. This batch is in a round robin technique basically. Initially we're gonna start from I think SVPN or SCOR. So Arun sir, over to you. We can the way we want to deliver this entire batch.
Your voice was breaking a lot, but not.
Yeah, I'm saying that you can start with the session now.
Okay. Okay. Good evening, guys. So we talk about VPNs today. Let me just share my screen. And if anyone has any questions, just feel free to put it in the chat window. Okay, so we'll start with VPNs. And VPNs are basically, they are part of your SCOR. They're also part of the separate VPN exam as well. And in general, VPNs are essential as well from a multi-vendor Cisco perspective. Just set up. Okay. So VPNs. Now, when we talk about, or when we say VPN, and I'm pretty sure everyone knows what the full form is, stand for virtual private networks. And they are nothing but they are a way for me to connect to remote locations or to remote sites together. Okay, that's what a VPN is really used for. Okay, so if I have a couple of locations, okay, let's say I have a LAN network here, and I have a LAN network here, right? And I need to allow traffic from, let's say, this A to B over our unprotected internet. Okay, so there has to be a way in which you can send the traffic without it affecting your security. Basically, you're trying to protect the CIA. Okay, confidentiality. Integrity, and the availability of the data. So by confidentiality, I mean the data, the private data, needs to remain private. No one should be able to actually see the data. Okay, so what is A sending to B, only both of those entities should know about and no one else. Integrity means the data should not be altered or modified while it's in transit. And availability, it's really how available a particular service or the data is for the users. Okay, so in essence, we're trying to protect this. Okay, so that's why you need VPNs. Okay, and VPNs in general, and when I just say VPN, they are just a logical tunnel. Okay, they're just a logical tunnel through which we can send our traffic or our data. since we are trying to connect two remote locations, or maybe two LAN locations, this would be LAN A and this would be LAN B. VPNs can also be called as LAN to LAN tunnels. Okay, LAN to LAN or L2L, whatever you might want to say.
Sorry, is it CCNP batch?
Yes.
Yeah, thank
you. Okay, that's really the essence of VPN, is not making it too complicated. That's the easier way to understand what VPNs are. Okay, and by default, when you create these tunnels, they do not offer any protection. Okay, which means this data is not protected, but it's still able to go or travel through the tunnel. Okay, but it's not protected. If you have to protect these tunnels, you implement IPsec VPNs. Okay, so if someone just says, hey, I need a VPN, okay, then a VPN is just a logical tunnel to have these two locations connect and transfer the traffic. It might or might not necessarily mean that there is protection for that tunnel. Okay, that tunnel protection or this confidentiality, integrity, encryption, and everything, it's provided by IPsec. Okay, which really is just your layer 3 security. Okay, your IP security, basically. Okay, and just to recap, your IPsec is built up a lot of different things, different frameworks, different protocol. This is not a single thing. Okay, it has something that we call as IKE, which is Internet Key Exchange. There are two versions for it, version 1 and version 2. Okay, version 1 is the older version. Okay, version 2 is the newer version. It offers more or better protection, better algorithms for encryption, hashing, etc. Okay. You also have what we call as 𝐊𝐢𝐧𝐬𝐬. Okay, this stands for Internet Security Association. And Key Management Protocol. Okay, so when we say we want to have IPsec VPNs, we're basically saying, hey, we want to have a logical tunnel and it needs to offer protection. And in order to build that protection, or let's assume an outer layering, okay, you need to use IPsec, and along with it, you need to use some of these protocols, IKE, 𝐊𝐢𝐧𝐬𝐬. Okay, so when you build this tunnel, this logical tunnel, okay, this is not protected by default. If you implement IPsec on top, you are then basically going to protect this through these algorithms. Okay, so this is your IPsec part, and within it, you have your VPN tunnel actually. And with this IPsec, you are kind of building a couple of tunnels on top as well. Okay, so with IPsec, and all of this is logical. Okay, you are not building an actual tunnel between the two routers, the two firewalls, anything. Everything is logical. Okay, so with IPsec, you basically have two tunnels that are built. One is a phase 1 tunnel. This is the phase in which you do negotiations. Okay, so both the peers, both these routers, both the firewalls, or one router, one firewall, they're going to negotiate some parameters. Okay, and a good way to learn that is through a mnemonic haggle. These are the parameters that that both the parties, peers, they negotiate. Now, what these are? Hashing. Okay. A is for authentication. G is group, which also called as Diffie-Hellman group. L is your lifetime. E is encryption. Out of all of these, lifetime is optional. And when I say optional, it means it does not need to match. Okay, the rest, all of these, they need to match at both the ends. Okay, so the hashing algorithm that you configure to be used on, let's say, this router, it needs to match on B as well, so that when they negotiate, okay, the negotiation is not going to fail. Okay, so phase 1 is these parameter negotiations. Okay, it's called phase 1. Okay, and phase 1 tunnel is really just this negotiation. There is no user traffic or no user data that gets transmitted in phase 1 tunnel. Okay, it's just these negotiations. Now, what could all of these be? First is hashing. Okay, this is protecting the integrity of the data. And it would be things like MD5, message digest 5, okay, MD5, HMAC, could be SHA, okay, could be SHA-1 family, SHA-2 family. Okay, so hashing, it is really just a one-way function. Okay, when I say a one-way function, what really happens is, let's say data, and we pass it through, let's say MD5 algorithm, and we get a value. Let's say A, B, C, D. Okay, we take the data, we attach the hash value to it, and we send it. Okay, when this reaches the destination takes the data, it will run it through the same algorithm again, and it should have the same value. Okay, so it will take what it received. Okay, so this is the value that it received, and will compare it to the value that it calculated. They should match. If they do not match, then that means that this data, it was manipulated or modified during transit, which basically means that the integrity was breached. Okay, So that's really the hashing part. That's why the hashing is required. And this value that is received, it can become different, or it can get altered with even the change of a bit, not just byte. Okay, byte is basically 8 bits. So even if you change a single bit in the data, it will change the hash value. Okay, so you cannot just change the data, and if both the ends are calculating the hash value, they're never going to be the same. It basically means that someone changed something in the data which caused the hash value to change. Okay, a lot of times if you download something, okay, maybe a software, the vendor provides an MD5 or a SHA value. Okay, it's a big string of characters, numbers, etc. Okay, so that's the purpose. So the vendor has calculated that value when it uploaded it to its server. When you download that value, you should calculate the hash value at your end and then compare both the values. If they both are same, that means that the data is safe. Okay, that there were no alterations that happened in that data. If those values do not match, then someone changed, or maybe you downloaded a different file. Okay, that's the hash part. Authentication is just authentication, okay, which basically means that I want to know who I'm trying to connect to. Okay, so I need to authenticate the other peer. And the authentication can happen either through credentials or password, which in here is basically going to be called as pre-shared key, or PSK. Okay, so you enter the password at both the ends, shared secret at both the ends, and they need to match basically. Or you can make use of PKI, which is basically you making use of X509 certificates. Okay, that's the authentication part. Group is your Diffie-Hellman group. These are again a set of algorithms which are basically used for key exchange. Okay, the higher the group number, the more secure it will be. Okay, so Diffie-Hellman groups, or the group numbers, they start with, I believe they start with 1 and then they go all the way up to in the 20s and everything. Okay, so if you choose a group number 20 versus a group number 2, the 20 will be much more secure. Okay, and that's where the IKE version 1 and version 2 plays a part as well. Version 2 offers more stronger and more secure algorithms. Version 1 offers not so stronger, because obviously this is the initial version that came out. Version 2 is kind of like an enhancement of version 2. Okay. Lifetime, it's just how long you want that tunnel to stay active. You obviously don't want it to stay active forever. Depending upon which vendor you're trying to work with, everyone will have a different value, and it does not need to match. Okay, if this router has maybe 2 seconds or 2 minutes configured, this one has 1 minute, they're going to both negotiate and settle down with one value. Okay, it will either be 2 minutes or it will be 1 minute. Okay, so that is one value that does not need to match. That's why I've written it as optional. The last part here is encryption, which is what is maintaining the confidentiality. I want to keep my data traffic private. No one should be able to see what I'm sending to the other end. That's why you use encryption. Okay, which could be something like DES, triple DES, AES, a lot of different algorithms. Obviously, you should be using more secure algorithms. Okay, for example, AES is secure. DES and triple DES are not nowadays. Similarly, SHA-2 is secure when you're trying to configure hashing. MD5, SHA-1 are not secure. Okay, so you need to be aware, you need to make sure that you configure and use the protocols or algorithms which are safe. Okay, so Kulbir has a question. Haggle information must match on both the sides. Yes, it needs to match on both sides. Okay, Haggle is really a phase 1 thing. Phase 2, you still do some of the negotiations happen again, but phase 2 is for a very different purpose. Okay, so Haggle is typically, or the negotiation or the primitive negotiation is basically your phase 1 thing. Okay, so once the phase 1 is completed, both the ends have negotiated these parameters, these values, and they are fine that, hey, these things match, we are okay. We then move into phase 2, tunnel. Phase 2 tunnel is what is actually called as an IPsec tunnel. Phase 2 tunnel is where you will actually send the user traffic. Okay, and within this phase 2, you again do some negotiations. The primary ones are going to be what is or how do you want the encapsulation to happen. Okay, now for the encapsulations, you would either do AH or you would do ESP. For mode, you would either do tunnel or you would do transport. Okay, you would either do AH or ESP, and AH stands for authentication header. Okay, let me write it here. Let's come down. Let's say encapsulation method. You can either do authentication header or you can do it through encapsulating security payload, which is your ESP. Okay, this is the most popular method of doing it. And recommended as well. The difference between the two, if I have, let's say I have a packet. Okay, this is my data. And I have what my layer 4 and my layer 3 information, which is my IP. Okay, let's say that's my packet. Now I need to send this packet across to the other end. So I have a VPN tunnel, I have an IPsec VPN tunnel. So now I need to do IPsec to protect it. Okay, so what does IPsec is really doing? It is protecting or encapsulating this packet. The tunnel concept is logical. What is actually happening at the packet level is the packet is being encapsulated. And how is it really being encapsulated is through either of these methods. Now with AH, what happens? We have this IP header. Okay. And we do, so let me just write it this way. So with authentication header, there is no encryption. Okay, there is no encryption, and that's why it is typically not used much. Okay, because if it does not offer encryption, then there is no use of actually using it. ESP offers everything that authentication header offers, and it also offers encryption. Okay, so typically in production and everywhere else, you're going to see ESP being used as the primary mechanism of doing encapsulation. Okay. Now, the other thing was the mode. In which mode do you want packet to be? We have tunnel and we have transport. Okay, both of them have both the modes. So AH has AH tunnel and AH transport. ESP has ESP tunnel and ESP transport as well. Okay, when you are trying to do site-to-site VPN, okay, now trying to do site-to-site VPN, you use tunnel mode, which is the example that we have here. This was an example of site-to-site VPN, trying to connect two remote sites or two remote locations together. Transport mode would be used for something like, let's say you're trying to send maybe tailnet traffic. Okay, you're trying to connect to maybe a server, okay, via tailnet or through tailnet. And you don't want to expose that tailnet because tailnet is unsecure. Okay, so for that, you would use something like transport. Okay. So tunnel is really you taking this packet and re-encapsulating into a new IP header. Okay, so typically when you're trying to send the packet, this would have a private IP address, let's say 10.1.1, anything, let's say 1/24. Right now, if you just send this packet over the internet, first thing won't be allowed. Okay, even if you do it through the VPN tunnel, someone can look into that packet and see what the IP addressing and everything is. If I re-encapsulate it completely into a new IP header, okay, a new IP header, then I'm basically protecting that complete packet. So I'm not revealing, or the packet won't reveal its private IP addressing space as well. So this would typically be a WAN or internet routable address. Okay, So if we have something like, say we have, so we have a client here. Okay, it's connected to maybe a router A, and let's say he's at 10, give me anything 0.1.3, for example. Okay, and this router here is it's connecting to internet, and here we have another location. We have another guy here. Okay, and they are at a 10.0.2.3, for example. Okay, this router here, that's the public address for this is 172.31.2. For this is 172.31. Let's say 2.2. Okay, and here we have our good old internet. Okay, so now if you just have a VPN tunnel, this guy can send traffic here, which will be the source will be 10.0.1.3. Destination will be 10.0.2.3. That will be the packet or the IP header, basically. If it goes through unprotected, even over the internet, anyone can take a packet capture and see what the details are in the packet, the IP addressing, etc., etc. Okay, but I don't really want to do that. So what I do is I take that data and that IP header. This is the original. Okay, I put in ESP header and trailer. Let's call it ESPH, ESPT. Okay, and then I add another IPsec header in front of it. Or you could just ignore this. Okay, this really would be your transport mode. Okay, so this header and trailer, and this is the difference between ESP and AH. This part here, this is providing encryption, right? So this data and this IP is in between these two packets or these two headers and trailer. So they are basically protecting, they're providing encryption. And authentication is provided through another header here, which is basically ESP auth. Okay, this is the authentication bit. With AH or authentication header, you will not have these trailers and headers because it cannot provide encryption. You will only have this authentication header because it can only provide authentication. Okay, and when you would do the tunnel mode, you would be encapsulating this complete thing here. So in front, you will get a new IP header. Okay, so here will be your original information. And within this new IP header, you would have the source as 172.31.2, destination as 172.32.2. So that will be your actual IPsec protected packet that will travel from here to here. And if this gets sniffed Okay, if someone takes a packet capture and takes a look at this, they really won't be able to see anything because everything here, or this is our main data. This is what we're trying to protect. This is protected inside. First, it's encrypted, and then at the outside, you have a new IP header, which helps it to hide the actual IP addressing that you're using in your environment. First thing. Second thing it's doing is it's making this packet travelable over the internet. Okay, because this is non-routable. It's using private IP addressing range here. Okay, so that really is your essence of IPsec VPN. That's what we're trying to do with, let's not just say VPN, that's what you're trying to do with IPsec. Okay, you're trying to encapsulate each packet, okay, into some of these headers, etc., so that no one can be able to sniff it. Okay, and then you have these travel through a logical tunnel, which is basically just saying, hey, this is the source, this is a destination, this is where you have to basically send the packets. Okay, so with the tunnel mode, you protect the complete packet. Okay, the complete packet is protected. If this would have been with something like transport mode, with transport mode, you only protect the data. Okay, so with transport mode, you would be, so with tunnel here, we are protecting everything, which basically means from here, from the trailer, okay, all the way up to the IP header. This is actually the tunnel mode. With transport, okay, with transport, you would only be protecting this. That's a transport mode. So with tunnel, you're actually protecting the complete packet. With transport mode, only the original data is protected, not the complete packet. Okay, so that's why you typically prefer to use tunnel mode when you're trying to do site-to-site VPN, which you see transport mode is usually when you're only trying to protect that payload, that data, which can be things like maybe you're trying to initiate some sort of a telnet or an unsecured protocol to maybe an internal server or something, okay? And you need to only protect that payload and not the complete packet. So in that case, you can implement transport. Okay. So that's your essence of IPsec VPNs. Okay. That's where you do the phase 1, phase 2. Okay. And phase 1 is just to negotiate the parameters. Phase 2 tunnel is actually where you send the user traffic. And that's why you have these encapsulation methods and encapsulation mode in here. Okay. So the actual user traffic, it belongs to the phase 2 tunnel. And one more thing, when you're trying to implement it on like a Cisco device, a router, or a firewall, remember the phase 1 tunnel that's built, it is bidirectional. Okay, so a single phase 1 tunnel is built between the 2 peers. but there'll be always multiple phase 2 tunnels built. Okay. So phase 1 tunnel, first is the phase 1 tunnel which built, it's bidirectional. Once that phase 1 tunnel is built, between or inside of that phase 1 tunnel, you then negotiate the phase 2 parameters, which are what encapsulation method to use, what mode to use, okay, the encryption method, etc., everything you negotiate within the phase 2 tunnel, okay? And the phase 2 tunnel is unidirectional, which basically means there will be one tunnel from A to B, phase 2, and there will be a second tunnel from B to A for phase 2. Okay, so when you do the configuration, we'll see that behavior as well. Okay, so phase 1 tunnel is bidirectional. There'll be always a single phase 1 tunnel. Okay, phase 2 tunnels are unidirectional. There'll be multiple phase 2 tunnels that will be built. Okay, and this holds true for both when you're trying to use either IK version 1 or IK version 2. Okay, so this is just really a way for you to do all of these negotiations and everything. Okay, that's why it's called internet key exchange. You're trying to exchange all the information, the key information, etc. Okay, to build your tunnels to help protect the user data or the user traffic. Okay. Any questions?
Sir, tunnel mode and the other mode which we are using, that we are using for the site-to-site or for remote?
Tunnel is what is typically you would use for both site-to-site or remote access. Okay.
Okay, and the other mode which we are using is a transparent, right?
Transport. Right. That is just to protect the payload. Like I gave an example, if you're trying to do some sort of a tailnet connection, it's unsecure. You only want to protect that tailnet payload,